We'd like to welcome you in a series of webinars designed for departments of transportation. I'm Terry Bills. I'm the Transportation Industry Manager here at Esri, and today I'm joined by Grace Sammartino, who's an account executive on our DOT sales team, and Stuart Rouse, a solution engineer on our transportation team. So today's webinar is focused on how to quickly and effectively conduct a damage assessment after a natural disaster. As we head into the beginnings of hurricane and fall storm season, we thought it would be appropriate to highlight some of the common workflows that we've observed relating to conducting damage assessments and how you can expedite recovery management with ArcGIS. Before we begin, I'd like to point out that we are recording this webinar, and while everyone will be on mute, there will be time for question and answers at the end of the presentation. You can type your questions into the question box, and we'll try to answer as many as time allows at the end of the webinar. Additionally, the slides that you do see today will be available to you on the GeoNet group, Departments of Transportation, as well as this webinar will be posted in roughly 3 to 4 days after today. So to begin with climate change and greater climate variability, highway agencies are going to be facing an increased number of natural disasters in future years. We're just now entering hurricane season in the southeast, and the current NOAA forecasts are calling for an above normal hurricane season. And as we know, last year, 3 major storms caused over $8 billion worth of damage in the south and southeast. This year, we also witnessed examples of flooding in Mississippi and Tennessee, among others, and closer to home here in California, the 2019 fire season continued a trend of increasingly devastating fires. In the immediate aftermath of these events, it's typically the responsibility of state DOTs to start an initial inspection and assessment of damages. Having the right tools in the field can make a huge difference in the efficiency of the damage assessment workflow and can help derive quicker cost estimates for reporting back to FEMA and federal highways. Secondly, DOTs need to make assessments of which roadways can be made serviceable with temporary repairs and which will require more significant restoration. Understanding which communities may be cut off and calculating revised evacuation routes are all part of this process. And then finally, in many instances, damage assessments necessarily involve an engineer for structural inspections. Ensuring the right resources are assigned to specific tasks is all part of the damage assessment workflow. So to dive into these concepts in greater detail, let me turn this over to Grace and to give us a fuller explanation of these workflows. So Grace, over to you. And
can you guys hear me?
Yes, we can.
All right. Well, good afternoon, everybody. My name is Grace Sammartino with Esri's transportation team. And as Terry said, transportation agencies are actively responding to an increasing number of environmental events. And these disasters can cause chaos for citizens, and mounting an effective response can be difficult. So today, this presentation is going to focus on a set of apps that can be put into service quickly to rapidly assess damage and provide a comprehensive way to track recovery activities leveraging your geospatial platform. So to kick it off, I wanted to provide context on why this solution is important for DOTs and agencies. Let's look at some facts. Emergency managers and directors from all agencies are challenged with unpredictability, such as fires, earthquakes, and floods. And the cost, size, intensity, and frequency of these events are sizable, as Terry mentioned earlier. Here's a graphic on the right on the amount of disasters in 2017 alone that cost taxpayers over $1 billion for each event. And when the roads are inaccessible, the goals are to make sure your citizens are safe, that the road gets cleared, and to get things up and running again. So what does that mean for your teams? Internally, the affected organizations face inherent challenges. And it's not just the emergency teams. These efforts involve a larger ecosystem, from bridge, maintenance ops, environmental design, hydraulics, to planning, finance, and communication teams. And these efforts require a greater level of coordination and sharing of data across internal and external stakeholders. And typically, this information resides in paper maps, legacy technology that's been dormant, and divisions which operate as data silos. So, by marrying data and location onto a centralized GIS platform, we hope that you'll walk away from the presentation with the following takeaways. First, we want to be able to help your organization manage and respond to disaster events faster. By exploiting location as a common denominator, we can pinpoint where our teams need to go and how to visualize and analyze the best course of action. Secondly, accelerate recovery efforts. You'll see in today's demo that the information flow is expedited and automated with modern mobile tools. And finally, we want to help you expedite the disaster relief funding. Within the solution, we have built in a smart form that is configurable and meets the federal aid requirements for reimbursement reporting. So I'd like to spend a couple more minutes setting up what you'll see in today's demo. The solution you will see today will be a simplified version of what typically happens during these damage assessment efforts. We'll demo how 3 field crews and an operations center perform different levels of inspection and analysis. The goal is to demonstrate an integrated workflow, which brings all sources of data, reporting, and process flows onto a centralized geospatial platform, so everyone is working from one version of the truth in real time. While we are going to demonstrate a more straightforward workflow, in reality, we get it. We realize that a damage assessment effort typically involves an intricate web of communication and triage, employing multiple engineers and specialists, multiple handoffs, and connections back and forth from field to office to external stakeholders. Fortunately, this solution will allow your teams to adapt the tools and apps to support the unique damage assessment workflows and processes across your organization. So here's what you're going to see today before I hand it over to Stuart. The demo will start with an environmental or emergency event. We're going to show you how maintenance crews doing recon work out in the field can use some modern mobile tools to identify and flag damage quicker. Next step is we'll send a residence engineer to do a deeper dive and inspect the damaged site. That information will be then analyzed at the incident command center, followed by a way to use that information to help inform and mobilize the right specialists to restore and repair the site. From that point, we will aggregate all that information from the series of inspections in close to real time onto a common operational view, as well as automate a federal reporting requirement for disaster relief funding. So I hope that gave you some context in what you will see in today's demo. And we truly appreciate at Esri the level of collaboration needed to mobilize the teams during these environmental events. So with that, I will hand it over to Stuart Rouse for the demonstration. Thank you.
Thanks, Grace. Today, we will look at a solution for DOTs to do initial damage assessment in an emergency management response scenario. The solution is comprised of integrated configurable web apps and mobile apps hosted on the ArcGIS Online or ArcGIS Enterprise platforms. We'll see how this solution helps to manage and respond to disaster events faster, accelerate recovery options by providing the accurate, timely information critical to deploying recovery teams, and expedite disaster relief funding by simplifying the form creation process. As we walk through the workflow, I will be assuming various roles and responsibilities from from a field crew doing damage reconnaissance to field engineers who will be doing the damage inspections, and then to incident command personnel in charge of overseeing the entire response effort. I'll start out by assuming the role of a maintenance crew member doing reconnaissance after several days of heavy rainfall. Currently, I am just clearing brush and debris that was displaced during the storm. I come across the bridge and notice significant scouring using a mobile app configured to capture damage information. I will generate a request for a resident engineer inspection. This application allows the user to simply click a button to capture a feature. Currently, this configuration allows me to choose the piece of infrastructure that is damaged and specify the severity of the damage. In this case, we have bridges, attenuators, and signals. And I can also take a picture of the damage for our records. So in this case, we're looking at a damaged bridge. So we'll click critical priority right here. And then we're going to take a picture of the damage that we see. And then we'll tap done there at the bottom. Now, since this app captures your current location and I'm not at the location, I'm going to delete this, but I do have one that I set up previously that is in the location that we desire here in Indiana. So what we're going to do is click send there at the bottom. So let's transition to a different role. Now I am a member of the Incident Command Center team. Our field crew has identified a damaged bridge and generated a request for the nearest resident engineer to inspect the damage in preparation for dispatching a recovery crew. The result appears in this work management app. Using this interface, I can see the location, age, and status of every work order along with the location of every field worker. I am only interested in unassigned work orders, so let's filter the map. This is the job that was just submitted. Oh boy, sorry about that. Here we go. All right, so while this spins up, here we go. So this is the job that was just submitted. And if we zoom out, then we can see that Freddie is in the area, so we will assign the job to him. All right. So the work order has been successfully assigned to the resident engineer. Now I will change roles again, put on my hard hat, and head back into the field as the resident engineer. My task will be to perform the initial inspection. So as the resident engineer, I should be seeing a new assignment in my queue in a moment now. There it is. And because it is a critical assignment, I need to acknowledge that I have received this assignment. Back in the command center, by hovering over the words critical priority, I should see that Freddie has acknowledged the work order, and there it is. And so now that I know, so back out in the field as Freddie, now that I know where I'm going, I need to make my way there. So I'm going to click this button here, this app integration button, and then click on navigate to assignment. This is our point-to-point navigation app. This app can be used offline. In a disaster scenario, there is a chance that cellular service will not be available. You can have all the data you may need preloaded on the device. That includes service roads and other proprietary map data that are not included with other navigation apps. So we'll tap go here. We'll accept. All right. Okay, so we zoom. All right. And so now we will pop back into Workforce. Now that I have arrived at my location, I can begin my work, and I can tap the Start button down here at the bottom. So back in the Command Center, the icon changes to let me know that Freddie has begun doing his work. So next, I will use an app that acts as a spatial inventory for all of the infrastructure that might need to be inspected. So again, here in Workforce, I'm going to click the App Integration button and then click Explore at Assignments. So this app gives you the ability to take your maps with all of your necessary data offline. When I identify the feature, which is this one here, its attribution information is shown. Click on bridge there, right. In this case, I also have a link to a form that will allow me to fill out and describe the damage that I am seeing. So I'll click Assess Damage here. So this is a configurable Survey 123 form. As you can see, some of the information is already pre-populated. Here, asset ID, the date, and the inspector. So pre-populating the data is beneficial in multiple ways. Initially, less time is spent by the user entering information. The chances the user enters incorrect information is reduced as well. And finally, time is saved on the back end by reducing the need for post-processing due to inaccurate data. So filling out the rest of this form, my role in this case is the resident engineer. And then here we will provide a phone number. And then this is the initial response. Some more information here that has been filled out for us already is some location information, the county, town, route number, so on and so forth. Close that up. So now we're going to start entering information about the actual road. So here we see that the road is passable and there are no restrictions, but here are some options that we do have. And we'll drop in some comments here, and then using the speech to text, we can say the roadway has no visible damage, period. So we can close that up. And then down here for the actual damage feature, we're going to say, so pre-populated, it's already there for bridge, and that's pulled in from the form previously. And then we're, so none of these, so none of these really apply. So we'll just go other, and then in the comments, we can say, we can use speech to text again. The scour here is pretty significant, period. Without action, this bridge could fail, period. So now that's there. And then we're going to also add a picture of the damage that we see. All right, and so the last part of this particular part of the survey, we're going to enter in some a cost for the rough order of magnitude. We have the emergency repair cost and permanent repair cost. We're going to enter in here. Let's call it 50,000 for a permanent repair, and so using my some of my training and my experience, I know that a structural engineer would probably be useful here. So we're going to say that a structural engineer should be sent out to take a look at the damage, assess it, and then go through the steps that he needs to do to get this repaired. So I've completed it, and now I'm going to send it off. So going back into Workforce, I'm finished with my work, and before I click finish, I'm going to add a note here. Finally, I can say, scour at this bridge, period, preventative action is necessary, period. See report, period. And now that that is complete, I tap save, and now I'm finished. And again, we'll see that Freddie is done with his field work. Right there, it says completed. And we also see the image that he uploaded there and the note that he included with his report. Now that the resident engineer has finished his work, the work order is no longer visible in this particular work order list. A work order for the structural engineer has been automatically generated from the report the resident engineer submitted. The same workflow can be followed for assigning the work order to the structural engineer. So we can click on it, we can see where exactly it is, and then we can go, we're going to assign it to this guy here, Stuart. And again, the image that was taken is attached, so we get that continuous flow of information from one person to another. And so once the structural engineer, once they get it, then it could be, then he can follow some of the same steps with the navigation and then filling out the survey. Right, okay. So here we go.
Thanks, Stuart. I wanted to point a couple things out. You've seen a lot of technology at work, and that triage process that we described earlier before. And a lot of the process that he pointed out is still being done manually. So again, we wanted to expedite the damage recovery efforts through these modern apps and suite of tools. So the mobile apps and the digital forms that are used can help your teams ground truth and validate the inspection efforts more efficiently in a consistent, integrated manner. So what Stuart's going to show next is a way that that data can be brought in real time to help inform the damage assessment efforts from a command center. I'll hand it back to you, Stu.
Thanks, Erase. So we've seen how command center analysts would use the work order management app to monitor and direct field assessment assignments. Now, I'll take the role of an incident commander who needs to quickly assess the progress of the damage assessment effort. So on the right-hand side here, we can see a list of all of the work orders. On the bottom, we see the counters for all the different statuses of the work orders. So we have 1 open work order, 5 that are completed, and we're looking good because we have no work orders open 10+ days and none that are past due. And again here on the right-hand side, we've got some other information that we can take a look at, like the status. And like we said earlier, we've got no assignments longer than 10 days, so that's looking good. We've got 5 completed, 1 assigned. So some of the same information, but in graph form. And if we were interested in one specific assignment, we can click on that one. And also as this pans in, you can see that everything is filtered based on the extent of the map. Over here on the left-hand side, we have that same image that can be accessed here. Also, we see some additional information, some additional details that go along with that work order. So this dashboard can be used for more than just monitoring these events in real time. As you collect data, you can start to identify areas that require frequent repair. For example, if the data suggests a particular roadway is flooded frequently, steps can be taken to implement preventative measures to ensure that road experiences fewer flooding events. You will not need to rely on only anecdotal evidence, like, I've seen it happen here, I've seen it happen here. You can have actual data to back up your claims.
That's a good point, Stuart. He talked about anecdotal data. So a lot of people that we work with have wonderful institutional knowledge. But what we wanted to point out, it's beneficial to have that authoritative data that your organization can use for effective decision making. So the final use case you're going to see is a way you can automate the relevant damage assessment data for federal reimbursement reporting efforts. Stuart, I'll hand it back to you.
Thanks, Grace. Finally, we'll look at post-event damage reporting. In this case, submitting FHWA damage reports. Once again, I'm going to put on my resident engineer hat. I need to create and submit an FHWA DDIR, or Detailed Damage Inspection Report, for the route I'm responsible for maintaining. This app will help me do that, assisting with investigating the damage in a given area, identifying and creating sites that contain multiple pieces of damaged infrastructure, and finally generating the report. So we're going to zoom in here on the area that we were just working on. There we go, so we recognize that. So first, we will capture all the damaged areas that will be a part of one site and display the information in an easy to read format. We're going to use this tool to select this area, and we see we do have one here. And so we're going to click this button. It's going to show us all the information there. So all this everything that we see here was collected by that survey. So next up, we're going to create the actual site. And using this editor tool, we're going to draw a rectangle around that. And we're going to enter some information here. So we'll just choose the disaster number. We'll just call this, and we'll save that. And so now we have our site. So this, so this rectangle is going to represent the site that we created, and now we have to create a report from the information that we have collected. So we're going to use a tool created by our partners at GeoCortex that will generate this report. And we'll click on that, and it's going to spin up here. And once that comes up, we're going to click to choose a site, and that disaster number 6785 is the same one that we have here, and we'll click here to create our report. We'll give the report a number, and we'll fill out some other information here. So we're at I-74, and then the milepost is 1.36. And we'll enter in some other information, permanent repair here, and then the inspection date, we'll just call it today. And we'll go next. So here we can input the quantity of whatever will be needed. We can also override the price list. So if a particular building material is cheaper or more expensive, we can update the form with the current cost. The form that is generated is going to be the actual form that is needed to be submitted to the FHWA for reimbursement. So let's kind of give an example on how you can do that. Let's change this to 35, and now the quantity to 2. Let's come down here and maybe put in a couple more items. I know this isn't probably very accurate, but just kind of show all of the different options that are here. Well, maybe not all of them, but a couple of them, right? So we've got some of the information there, and then we'll click next. And over here on the right-hand side, we've got the total cost. These are the items. This is just a summary of everything that we have input here. We can either do it as a draft or as complete. And so here we click the save button. So the form that's going to be created is going to be a PDF. So we'll get a link here that we can click on. And so all the information, again, that we input into that form is now populated here. We've got the report number, inspection date, disaster number, the route number, and all that information. And then again, here the actual items that we said that we're going to need, the unit price, and then the quantity. Right. So then you've got your total down here at the bottom. All right, I'm going to jump back over here. So in summary, this workflow supports the complete process a DOT would go through in an emergency response scenario, from assessing damage in the field to requesting funds from FHWA. The tools help to manage and respond to disaster events faster, accelerate recovery operations, and expedite disaster relief funding. Thank you. Back to you, Grace.
Thank you, Stuart. To everybody out there, we hope you enjoyed this webinar, and we wanted you to show you a way you can spin up an integrated suite of apps quickly to more efficiently support your damage assessment and recovery efforts. And I do want to point out, we were able to do this by organizing all your disparate sources of data and processes and organize all that information by location. So everybody's working from the same page. And everything that you saw today was 100% configurable, no custom code required. So with that, I will hand it over to Terry Bills for the wrap up. Thank you.
Okay, great. Thanks, Stuart, and thanks, Grace. So this is the opportunity. You can type in your questions into the question box, and we'll open up the question period. And somebody did ask whether we will make the slides and the recording available. Yes, the slides that you saw today will be posted on the GeoNet Departments of Transportation GeoNet group, and then we'll have the webinar posted in roughly about 3 or 4 days. Okay, so there's and Grace, if someone wanted to implement the workflows that you demonstrated today, how would you recommend that they get started?
Great question, Terry. You have partners. Every client has Esri partners across the country that we can support, and we can put you in touch with your local account manager to put these efforts at work. So no problem with that. Okay, and let's see, there's a question, which app was used to create the DDIR? Stuart, you want to take that, or Eric?
Yeah, sure. The DDIR was created using the GeoCortex workflow product, and that is also configurable. It's provided by GeoCortex, and it plugs into Web App Builder as a widget and can be called from Web App Builder. So we were able to call up the DDIR, the FHWA form, populate all the form fields, and then generate the draft. That draft, by the way, once it's saved, once it's generated and saved, you can go back and make changes to it and make edits to it on the fly. Now, Stuart didn't show that, but you do have the ability to go back after it's been initially filled in and add more information to it over time. So you can actually build on it as you go and collect more data about a damaged site.
Okay, and maybe a couple of questions relating to the communication. So the question is, what is the means of communication from the field to the command center? Is it cellular, etc.? And then the reverse of that, how do these apps work when there is no cell service? So maybe you can speak to the offline and
So in terms of offline communication, every one of the apps that Stuart showed is designed to work offline. So the surveys are completely able to work in an offline capability. That you still have a GPS signal on your phone, so you can still collect your location. In terms of Explorer, it also has an offline capability, so it's preloaded with all the data it needs to go into the field, so you can select that bridge location, and then it has all the attributes that it passes over to Survey 123 and fills in the form. And then the same is true with Navigator. It also has the ability to, you have the ability to upload it with all the drivable base maps that you need, all the routable base maps. So that can be all done ahead of time. And then Workforce is the one app where you wouldn't need to have an internet connection to get additional additional work orders. So if I'm out in the field and I'm in an area where I don't have cell connection, I'm not going to get those work orders. But as soon as I get into an area, I would have those again. And I know that the workforce product team is working on that right now. I believe that's set for a pretty imminent release. I'm not sure of the timeline, but I know the product team for workforce is building a complete offline capability in. However, in order to get additional work orders, you're going to have to be in places where you can connect to get those. So, but the fact of the matter is it does have the ability currently to cache those work orders it has and store them. So when you're out in the field, you can click on that work order and then launch into Navigator and then launch into Explorer, but it wouldn't be able to pick up anything new. Survey 123, again, when you've filled out that form and you hit submit, if you're not connected, it's just going to store it in its offline database. And then as soon as you're in a place where you can't connect, it's going to submit. So all that's taken care of.
Okay.
And then
thanks,
in terms of the communication, that was a two-part question, if I recall. So the first question was, how do all the apps work offline? The second part is, how do all the apps communicate? Well, in the case of Survey 123, that communication is through push notifications. So when the work order was pushed out to Stuart or to Freddie field worker, a push notification was pushed onto his app, indicating to him that a new work order had come in, so he could see that. So we're not doing anything with cellular connection. We're not doing anything with messaging. It's all just through the notification channels built into the apps. And then I also forgot to mention Quick Capture. That is also an app that's designed to work offline. So those maintenance workers who encounter that damage initially, they don't have to be connected to the internet to capture that data. Now, as soon as they get into an area where they have a connection, they can hit submit, or if they get back to their maintenance garage and they connect to Wi-Fi, they can hit submit, and then folks back in the Instant Command Center can be notified that new work has come in.
Okay, thanks, Eric. So another rather interesting question. There's a question as to whether we're actually integrating real-time weather data into these apps. Can either Eric, you or Stuart want to speak to that about the potential or the ability to integrate real-time weather?
Yeah, sure. So in terms of real-time weather, certainly in the Workforce app and certainly in the dashboard, in terms of Survey 123, and Quick Capture doesn't use a map. So that one is just, it's where I am. It's designed to kind of be like, it's basically a windshield survey. So I can do those things while I'm moving. So think of like a night inspection where you're collecting retroreflectivity data. In the case of damage assessment, I could be driving, just marking things by tapping on the buttons and then holding up my phone to capture a picture. So in some cases there, you might stop to actually capture the picture, but you could theoretically do that while you're moving. In terms of Survey 123, it does have the ability to upload a web map. However, it all depends on your connectivity. So if you're in the field and you want it to provide weather to people, that's all going to depend on whether or not they have an internet connection if they're out in the field. I know in some of these states, like in Colorado, it gets pretty remote and Wi-Fi connectivity is not so good. In the case of, say, hurricane damage, you may be in a situation where, you know, that day after the storm has passed, you still might not have cell connectivity recovered and repaired and restored. So it may not be possible to have live weather in the field, but certainly on the apps back in the office, we can have live weather and we can notify folks when they're in harm's way if they're in an area where bad weather is starting to pop up.
Okay, thanks. So there's a question quite often federal highways is really interested in having a lat long. Can you speak to the ability to not only capture sort of location information with some degree of precision, but also on the pictures as well, and maybe talk about the different technologies that also can be integrated that could give greater precision to the data if that was actually required. Eric, you want to take that one, or Stuart?
Sure.
All right.
Sure. In terms of precision, in terms of the precision of the device, we're dependent on whatever the device is capable of providing us. So if I'm out in the field with a cell phone and I don't have any additional GPS devices with it, I'm going to get what a typical cell phone can carry, which is right around 3 meters, 15 feet. And then you can improve that by adding on GPS devices that have higher capability. I know there are a couple models out there that get you in the 9 feet range and 8 feet range, and then you can progressively get that even better by going into high precision devices, which can improve the precision even greater.
But if they were asking about maybe like the possibility of getting the lat longs like on the images that are captured, I do believe in quick capture that option is available. So when you snap that picture, there's some you can get. Well, it may not be out now, but maybe at some point when you snap that picture, some of the location information will be on the picture. Am I right about that, Eric?
Yeah, that's correct.
Yeah.
You can.
Yeah. So if that's something that you're looking for, that high accuracy data that you're looking for, that could come from the GPS device that's attached to your phone to get that location. It can be kind of overlaid at like the bottom, maybe in the corner of the image.
Okay, so thanks. And so there's another question that really has to do with what is the software that's required, and then what were the apps so if you could go through workforce and collector and survey 1, 2, 3 and navigator, were there any others? But then also what was what underlying software does someone need?
As far as the apps go, well, we started out with quick capture, and then and that's where that's the big button app. You tap the button, you take the picture, and then the point is dropped wherever your current location is. And then from there we moved on to workforce, which was the web application and the mobile app. So there's the kind of the like the back office version, and then the out in the field version. And then there was Explore for ArcGIS, which is the inventory, where it's just a bunch of all of your data kind of on an offline or online map that you can tap on to get information on it, which took you out to the survey, which in this case was survey 1, 2, 3. And that's where you just fill in information. You can take pictures and such. And then navigation was the point-to-point navigation deal that we had there. It was what dashboards was the dashboard with all the information on it. We had the map and then the counts and all the different work orders that were available, and then finally Web App Builder was for the site builder. And again, everything in there was all these things were configurable, and everything inside of a Web App Builder outside of the GeoCortex application was provided by Esri, and again, no code was involved.
Okay, thanks, Stuart. And there is another question, I guess, back to you, Eric, in terms of being able to integrate on on-site measuring technologies. So maybe you might want to speak to the ability of collector, survey 123 to your device to be able to communicate with a higher precision GPS, as well as such technologies like IKE and others, if you speak to that.
Yeah, so in terms of the GPS, I know Bad Elf is a GPS model out there that integrates via Bluetooth and also can just plug into, like, for instance, in the iPhone's Lightning connector at the bottom where you would typically power it up. You can plug in the GPS dongle, and then IKE is a device that clips onto the back of your phone. It's called the Spike Laser Rangefinder, and with that you can capture distance to certain targets. Now, typically the optimal way to collect those targets is, I'm standing at, say, a sign, and I'm facing my phone directly at the sign face, and I'm able to measure the height of the sign and things like that. So that may not play very well with damage on a road or damage to a bridge, unless you're able to really get into a position where you can, safely capture, like, damaged columns and things like that. But it does have the ability to measure the distance from where you are to where that damage is, and then calculates the difference, and you can incorporate that into Survey 123 and do some calculations on the fly and do some markup photos. As you capture those things, you can mark them up with photography, and then submit all that data in your survey, so it just is part of the of that damage point or line that you collect in the field.
Okay, thanks. And actually, everything that you've seen here today is actually not just applicable for state DOTs, but really across any of the transportation agencies. So, for example, in the railway, I know that we've had all of the Class 1s have actually used very similar, these sorts of workflows, and even incorporating sort of drones to capture images from locations that are not easily accessible by foot or by car and such, and incorporating that back end and transmitting that back into that command center. So there's obviously, this is the core technology, a lot of the core infrastructure, but you can add on any number of other technologies that can feed into the core software that you've seen here to add additional whether accuracy or functionality as well. There is another question having to do with the GeoCortex widget. Does that require the question is that part of the ArcGIS software package, or is that an additional acquisition, a software piece that would have to be acquired?
Stuart, you want to take this one, or you want me?
You got it.
Okay. Yep. So the GeoCortex form that you saw, the workflow, that is an add-on. You would work through Vertigis, which is the parent company of the GeoCortex products, and they would provide you with the licensing and the software that plugs into ArcGIS Online, and then makes that that capability achievable through Web App Builder.
Okay, and so let me just. So I do have a link here actually to the Federal Highways Damage Assessment Report. You can see that we do have not only the GeoCortex, but we do have other partners that have created sort of widgets for both federal highways as well as for FEMA as well. So we'd be happy to point you to those. Other questions before we close this off? And Grace, anything that you want to add before we close this out?
I was just going to say, if anyone requires additional information, feel free to put that request in through this webinar, and we'll make sure we point it in with the right contacts and the right support for you. This was just a workflow to give you an example of how to integrate it, a suite of apps for damage recovery efforts, but we're here to design a workflow that's specific to you. So we look forward to working with you.
All right, and with that, I will close this off. We would like to thank all of you for attending today. There is a short little survey that we'd appreciate if you could take at the end. And we look forward to seeing you on future webinars. So again, thank you. Thank you, Grace. Thank you, Stuart. And thank you, Eric. Appreciate it.
Thank you.
Thanks all.